Welcome back. I hope you are enjoying this course. I want to start a small project. This project is entirely optional, but I think it will teach you a little bit more about programming, and in particular how to use it to solve some problems. I think a nice way to start is to try to build your own little application, and I selected an application that kind of makes sense. So what I want to do is I want to teach my computer how to play Blackjack and build an application which I can run old school in my terminal. For that purpose, I think it's quite useful to switch from Spider to Sublime. I mentioned Sublime before. It's actually not an IDE. It is a text editor, so you can't execute any code in it. But the benefit of Sublime is you can easily operate various files at the same time, which becomes a bit more difficult in Spider. You can work on projects in Spider, but honestly, in particular, if you want to integrate some testing, I strongly prefer executing my program in the command prompt. And you will see later in this actually a few sessions later, you will see why this actually makes sense. Okay, so the first thing to do is you have to check how to play Blackjack. Now I assume you already know that. If you don't know that, I say check out Wikipedia or some nice YouTube videos and you will figure out how to play Blackjack. I'm a big fan of gambling, so I went to quite a few casinos and of course I lost money, but I enjoyed the game. Now Blackjack is quite a simple game, so the first thing you of course have to do is you have to kind of start a deck of cards. That's the first thing you have to implement. Then later we have to think about players and how to actually put this game together. Now in Blackjack you are given in the first round as a player 2 cards, and they have different values, and we will come to this in a minute. And you have to try to go up to the value 21, adding your cards together. 21, if you reach 21, that is Blackjack and you win the game. If you go over, you are bust. And this is basically what we need to implement. The first thing you noticed is in Sublime, I added a folder into my project. So you just go to project, you go to add folder into project, and I basically have done this. I just call this Blackjack Live. So this is our live project. At the moment there's nothing in it, except one file which I call main.py. I strongly advise you to execute your code in one file and import whatever you build outside in other files to import it into the main file. This is good practice. Now the first thing I want to do here is I want to start thinking about the building blocks of this game. So first we have to teach our computer what is a card. That's the first thing. Yeah, so the computer has to know actually what is a card. The next thing which would be helpful to build as an object is a deck of cards. So the deck of cards holds 52 cards, and we have to teach how to actually put the cards into the deck. Once we have a deck of cards, we then want to reshuffle the deck of cards. Obviously, we want to have different cards all the time. And then we would start our actual game. So in this session, we focus on creating a card object and a deck object and doing some reshuffling. Okay, let's get started. So first here I will start a new file. I save this file as card.py. So I always use a lowercase for the name of a file, and of course for class names I use the upper camel case, which is standard. I put a docstring at the top here, and I just say here it determines the card class. You don't have to do this, but over time I might maybe just add a few more comments. It's just kind of nice to keep that. So we start by specifying a class here. We call this card. And then of course we have to think here how we want to initialize a card. Well, what are the main attributes of a playing card? The ones that we actually care about are the rank of a card, so a 2, 3, 4, 5, then check, queen, king, ace, and the suit, say diamonds, hearts, and so on. So that's I think quite obvious. So let's just implement that first. So we do the dunder init method, do self, and then we specify rank and suit. So self.rank. So that should be quite straightforward. So let me just maybe try that first. Now here you have to be always careful to make sure you save it. So saving in Sublime is simply Control S. That is saving the currently active file. Yeah. I go into main, I'm in the same folder, so I can simply say from card import card to actually import that. I give it a little bit of space. I might again add a docstring here and just state the obvious that this is the main file. Main file to execute code. And we might add a few comments, or you can add a few comments later. Okay. Good, so we have imported now our card object, so I should be able to play around a bit, which I would do. So basically here I'm starting to test whether the code actually works. So do another docstring here, and just say let's basically initialize a few cards. Just want to check whether this is all working as expected. Let's do a card 1, and I call this of course cards. I now use my rank, and my suit would be hearts, same. I can just copy paste that to speed things up a bit. I do a second, I do a third card. And I just want to have a little look how that actually works. Do we get any error messages? I put a king here. We stick with hearts because I'm too lazy to type. We do an ace here. Okay, that's fine. So that is quite a good start. And then of course we could start printing and just checking what we get. So for instance you could start printing. Let's do card 1 rank, which should give me the rank 7, and if I do plus here, because it's all a string, it would be kind of added together. I do a space here to make it a bit better, and I do card 1 dot suit, so I get access to the attribute suit. So let me just check whether I messed up at one point. I now move into this folder. Let me just move into this folder. Here we are, projects, Blackjack Live, here we are, CMD, and I'm already in the right folder. Okay, I just make that a bit smaller, move it up a bit, and let's just run this. So Python main.py. Okay. So what I get is 7 hearts, as I would expect. Yeah, so that is working quite nicely. I just keep it open all the time and go back into my file. So that seems to be kind of nice. Of course, if I now just print card1 just like that, what would you expect in this case? Think about this for a minute. Well, we can just give it a go, and what you get is basically, it tells you that this is a card object, so that's not very interesting, and then you get a number, and this is simply a number. This refers to a place in memory. So this is basically where this object has been stored. But it doesn't give you anything else. It doesn't give you a technical description of it. So it is not really great, and I think it's quite nice and useful to actually teach the computer what the card is. So what we can do here in our cards class, we can just do a dunder representation and basically tell Python what to do when printing a card. We can just do that. So we can just say, okay, here a return statement, return, and we can simply return a formatted string. We already know how to do this, and it would be simply self.rank using the placeholders here. So that would be basically self.rank of self.suit. So if you do that, that might look a little bit better. So I save that, I go back here, I go into the up arrow, which goes back to my previous command in the command line. I execute that, and now I see 7 of hearts. Now this is pretty good. So now actually I don't need my self-constructed print line. It's not really interesting. So I do a control slash here to simply comment that one out. And so that looks fine. Obviously, hopefully that should also work with the other cards. We can just try this one more time before we move on. Let's give it another go, but thus far it seems to be all working fine. Okay, so now we have the cards class implemented. But of course the interesting thing in Blackjack is that the rank of course matters, but not in all cases. So for instance, in the case of a king or a queen or a jack or an actual 10, they all count for 10. Now that needs to be implemented. We have to kind of think about how we discuss the actual value in the context of Blackjack. Now there are different ways to think about this. One could, for instance, do another attribute here, and you could explicitly store the value. That you could do as a matter of principle. You could actually do that. You could also do a method in this class, an instance method, where you could basically call this method on a card, and it would give you the value. That again is possible to implement. However, I think it would be kind of nice to introduce here a property. A property can be called just like an attribute, but in particular in this case, what we do is we by the rank actually defines the value. So having this as a property, I think, would make quite a bit of sense. But honestly speaking, you can do different things here. So that's a matter of choice. Now to get a property, here we just use a decorator, and then we get automatically in Sublime already the structure of, in fact, looks like a method call. The decorator basically tells Python that this should be seen as a property. The main difference in terms of programming is later when I want to access the property, I just treat this like an attribute. I just use the dot operator, state the property name, and that is it. So this is basically how it works. Now, in the case of a method call, as we know, we actually have to call it, so we have to have open close brackets. So that's technically the difference. Of course, there are plenty of other differences. I don't want to go into the details at this point, but it's one way to think about an implementation. So let me call this differently. I just actually don't need this line here. Let's call this here value. And then we have to think about this a bit. The main issue here is that the ace is a bit of a trouble. Yeah, so if it is an ace can be an 11, but it doesn't have to be an 11. And we have to try to actually work on this a bit later. So what I think would be useful to do, and again we can make mistakes here, so that's all live, you know, for sure I will make mistakes. Let's initially just start with the ace and declare the value as 11. Yeah, so that would make sense. And then of course all the values from 2, 3, 4 up to 10 are anyway equal to their actual rank. So we can use the rank, which is now implemented here as a string, convert the string into an integer, and use that integer as the value of the card. And whenever that is not possible, so once you go into check queen and king and ace, we just assign a different value. Yeah, so one way to do it, I think, let's see, is to use here an if command and say if self.rank is equal to ace. So if I have an ace, I would now implement the value of 11. Later we have to change that, because if you go above 21, this is normal blackjack rules, and you have an ace and you would be usually bust, the ace can turn into a 1, which might save you. So we have to think about how to implement this later a bit more carefully. So, but if it's not an ace, what do we do? What I think would be quite smart to do is we can use here a try and try to convert simply our rank. Yeah, so we just set our value equal to the integer, so the integer function converting self.rank into it. And of course that won't work. That certainly won't work for the check, for the queen and for the king. The ace is already taken care of in the if statement here. So if that doesn't work, we have an exception. So in the exceptional case we just assign 10, which is correct. Yes, for the check, for queen and king, the value will be 10. Good, we are here, and then we just simply return value. Okay, so now let's see whether this actually makes any sense. So as always, you have to test whatever you have done. That's the best way of doing it. So below here, let's check our values. Yeah, so what we do is we go into card 1, I go into value, and I do this also for the other ones very quickly. Let's just copy paste that and let's check that. Okay, that's fine. We already saw that this representation works, so I comment that one out. I copy this. I should actually start paying for it, but at the moment I just use the free version. Good, let's run again my Python main, and here we are. So we get a 7, we get a 10, and we get an 11. That seems to work fine. Yeah, so that's actually working quite nicely. Okay, that's pretty good. Good. Now we have our cards worked out. We know the values based on the rank. At the moment we take the ace with a value of 11, but that is of course, we call this a soft hand in blackjack. So if we go above 21, the ace would actually turn into a 1. And so that we have to think about later in the gameplay. Next, I think it would be a good idea to start the deck. Let me just save that here as deck.py. Now again I put a doc string here. You can add a few more elements to it. So basically this here determines the deck class. I can't type anymore. Here we are, and we just start class deck. Here we are. Good. Now in terms of attributes, I'm not yet really sure what a deck should be able to store. Let me just start with the dunder init function here. Obviously we have to kind of store some cards on a deck, so it would be plausible to start maybe with no cards at all and later basically add cards to the deck. Again, you can do it differently, but that is actually quite an elegant way of thinking about this. Yeah, so we have initially an empty list. So we use a list to store cards, which kind of makes sense because we can change the order of cards when we start reshuffling the deck. So that kind of makes sense. So what we need to do now is we have to start adding some cards to it. So I just use a method here, instance method. I just call this add cards using the lower snake case convention. I just use self here, and now we have to think a bit about this. There are different ways to do this. I just now already put card in here, so I basically use as an argument the card object. There are various pros and cons of doing that, and we will see this a bit later. The first thing to do is we now have to specify our suits, and I just put this here in a list. All the people that enjoy gambling know this. We have clubs, we have diamonds, if I can spell it. Then we have our hearts. Always notice this has to be all indicated as strings, as a single or double quote. Both works, but don't mix it. And some spades. Okay, so that's fine. Then we have our ranks here, and that's another list. So it's 2, 3. I really have to say it's very relaxing, this kind of work. You just really think what else to do in lockdown. You know, why don't we just code some blackjack? Yeah, why not? It's a Sunday well spent, in my opinion. So here we are with up to 10. Then we use a jack here and a queen, king, ace. So we are done. Good. Now what we do is we basically use our card object here to create a card that has a certain suit and a certain rank. Take that card and add it to self.cards. So basically we add card after card to our deck. By specifying all the possible suits and all the possible ranks, if we do this in a double loop, we ensure we end up with 52 cards. Yeah, that is the idea. Okay, so let's just start with the first loop. So for suit in suits. So this basically goes through my first list, starting with clubs, going to diamonds and so on. Then I go to the next one for rank in ranks. Okay, now I initialize a card is equal to card, well, rank suit. Yeah, so this is what I do. So when you go back here into the cards class, we have rank and then suit. You know, we have to be careful with, of course, the position of the argument. These are positional arguments. Otherwise, we have to spell it out. Rank is equal to rank. We can also do that, but there is no need for this. Yeah, so that should be perfectly fine. Good. So if I implement it, as you can see here, I don't have to import the card class into the deck class file. I actually call the card class from my add cards method. Yeah, so it's included here as an argument, because I want to do all the importing in the main folder. Honestly speaking, we don't have to implement it as I do it here. You can do it differently. I quite often like to do it this way because it's kind of obvious now, just by looking at the code, that I need to understand, actually I need the card object, the card class, to do my deck. So I see the interrelationship a bit more clearly, but honestly speaking, that can be done differently. The next thing is I now use self.cards. It's a list, so I can use the append method here, and I add the card. Obviously, I don't have to use 2 lines, yeah, so I can just take this in here and it would also work, yeah. But you know, that's at this point I think it's quite acceptable. Let's see whether this actually makes any sense, whether this actually works, and let's execute that. So we go back into main. We now import our deck class, and further down below we just start our deck. So deck is equal to deck. That's it. Now we can simply check if we look at that deck.cards, but this should be now an empty list, and then of course we can now use our method call, so deck.addCards, and we pass in card. Yeah, so that's actually how it was implemented, as add cards, and then we pass in card. So that should do exactly what it's supposed to do, fingers crossed. And let me then just print here again the deck.cards. Okay, let me just see. Let's do that. The values work, so I can comment that out, so that's fine. We also don't need the cards here at the moment. We just comment that out. And let's run that again. Okay, so you see the first one is our initial print command, which is just an empty list, and then we get our deck of cards. So starting from a 2 of clubs, going all the way up to the ace of spades. Yeah, so that looks good. That looks quite promising. Now, sometimes it's useful to actually have the len function defined. So if I now do something like this, len, referring to deck, it, let me see what happens. Well, you will get an error message here, because deck has no len function. Now, of course, you could quite easily do this, go to the attribute, and run this, and you see you end up with 52. Yeah, so because obviously the attribute, which is a list, has a len function. But quite often when you use this code, and you have other coders on a team, it's kind of nice that the actual class understands what len is. Yeah, so otherwise you have to know that this particular attribute of the deck class is actually a list, and I can call the len function. So to make things a little bit better, it might be helpful to actually implement here the dunder_len method. Anyway, it's just a line to add. It makes things a little bit better. And basically what you do is you just simply return here the len function called on the cards attribute. Yeah, but then I don't have to know that. That's the benefit. So now when I call I just do this here below. If I just call len for the deck class, it should work as well. Fingers crossed. Let's do that, and it does. Okay. Now this is the end of the first session. The next session we have to start thinking more carefully about testing our code. Thank you very much.